Okay, so we're going on to 5-7, kind of out of order. But the reason is for this is because we're going to be, for the next several sections in 5, we're going to be doing a lot of factoring. Decided to do it in this order because I think this is the best way to learn it with the different kinds of factoring. Now, we started factoring by taking out the GCF. That's really good. That's one type of factoring. Now, there's so many types of factoring. Ways to do it. Some are really easy for certain cases and so on and so forth. So we're going to be going we're going to do each one of them. So right now we're using the factoring pattern for x squared plus bx plus c, where c is positive. So this is our first case. So this is what we're going to learn. We're going to learn how to factor this kind of case. So if we have this, we know that this is a trinomial. Because it's a polynomial, but it's more specifically it's a trinomial because it has 3 terms. There we go. Hopefully old news for us. Okay, now when we have this x squared plus bx plus c, we know we're going to say that b and c are integers. So b and c need to be integers. Okay, so we know what integers are. It could be negative, it could be positive, but it has to be like 1, 2, 3, 4, -1, -500, so on and so forth. Okay, now general factoring form of trinomials, there we go, is going to be, it's going to look like this. So I always kind of like to do the little parentheses first, and then we have, it's going to be x or whatever your variable is, plus or minus a number. X plus or minus a number. Now, when I say plus or minus, I'm saying there could be it could be x plus a number or x minus a number. Okay? It's not going to be both of them at the same time. Those are the kind of forms. Now, in this case, since c is positive, it's either going to be x plus a number, x plus a number, or x minus a number, x minus a number. You're either going to have both positive or both negative for this case of c being positive. Okay? So, now that we're going to do that, we're going to start with some examples. Okay, so in order to factor it, okay, so we have our the same form, and we know that our 2 numbers that we need to find need to both be positive or both be negative. And the way we think about it, it needs to add to this number, so it needs to add to the middle term, and it needs to multiply to this number. Okay? So, the way to think about that, so we need to figure out kind of some factors of 15 and see which of those will work to add up to 8. So, the first one that comes to mind for me is 3 and 5. So, I know, and that actually kind of works in our case, because 3 times 5 equals 15, so that multiplies to 15, but 3 plus 5 also equals 8, and that's exactly what we wanted. So, once we find those 2 numbers, we now are going to factor. So we have the x's right here, like kind of like our example up here, and I'm going to use 3 and 5 because those are our numbers, and they're both positive because a positive 3 times a positive 5 is 15, and a positive 3 plus positive 5 is 8. So we're factored. We got it. But a way to make sure that we did it right, again, you're not going to always need to do this, but we're going to check this example by the FOIL method. Remember, first, outer, inner, last. Okay, so we're going to say the first 2 terms, so x times x, which is x squared, and then we have the inner or the outer terms, which are x and 5. So that will be 5x, and then we'll have the inner ones, which is 3 and x, so plus 3x, and then multiply 3 times 5, so that's 15, and that gives me x squared plus 8x plus 15, which is exactly what we started with. So therefore, we did it correctly. We factored it correctly. So if you ever are unsure, multiply it out. We know how to do that. Okay. So we need to add and multiply. So it needs to add to 5 and multiply to 6. So again, if you forget which one, I was taught back in Texas, A&M. We had a college, Texas A&M. So that's how you write A&M. If that helps you. Yeah, if it doesn't, then don't worry about it. Okay, so it needs to add to 5. And multiply to 6. So I need to think of some 6. Oh, 2 and 3. 2 times 3 equals 6, and 2 plus 3 equals 5. That's exactly what I needed. Okay, sometimes you're not going to always think of them right away. You know, you might have to be like 6 and 1, does that work? You know, kind of thing. But in my case, I got it. So now I'm going to have my x's, and I'm going to have 2 and 3, and they're both going to be positive because in order for this over here to work, they both need to be positive. Okay? Okay, now, so we're getting to example number 3. It's a little bit of a change up. You see how we have a negative 10 right there? Okay, we still have the positive c because that is our form right now. But you know how before, if you look up before, the first two, they were c. We know c was positive, but also in front of our b was positive. Okay, so therefore they both end up being positive. Okay, that's kind of a trick. Whereas if you have this, the c is positive right here, but the b is negative, they're both going to be negative, and you'll see why in just a second. So it just kind of gives you a kind of head start on it. So we need to add, multiply. So we're going to add to negative 10 multiplied to 24. Okay, I know 6 and 4 equal 6 times 4 equals 24. But 6 plus 4 does not equal a negative 10. Okay, I just told you that if this one's negative and this one's positive, that they're both going to have to be the negative. So, a negative 6 times a negative 4 still gives me a positive 24. And a negative 6 plus a negative 4, let me write that, negative plus negative 4, keep that in parentheses, equals a negative 10. So, therefore, I'm going to use x minus 6, x minus 4, and that's going to be my factored form. Okay, so if it's a negative in front here but this is a positive, then you're going to have 2 negative numbers, whereas if it's both positive, then you're going to have 2 positive numbers. And our last example, so add to negative 10 multiply to 14. Okay, so factors of 14, 1 and 14, so 1 times 14, that equals that, but oh, they have to both be negative. Okay, that's still not going to add up to 10. Okay, so let's think of another one. 2 and 7. 2 and negative 2 times a negative 7 works, but that doesn't add up to negative 10. That adds up to negative 9. And those are all the factors of 14. So, in this case, we are going to say that this is prime. Ooh, why is it not writing? Hold on. I'm having some writing difficulties. Okay. It won't click at all. Oh, lordy. Okay, let's see. Okay, well, my pen stopped working, so if I had my pen, I would write prime. And let me finish by saying, in this case, it is prime for our fact right now. Eventually, you'll learn how to figure out and not put prime. But for our purposes right now, you're putting prime. Okay? Okay, so there you have it. And